Welcome to C# for Crestron programming. In this video, we will be further examining the modifier static. The keyword of static can be applied to a variety of items, including methods, fields, classes, and constructors. Whenever applied, it indicates that there is only one copy of this item in the program. We will be starting with a C# console app.NET framework project called static keyword. We have also added 3 additional classes called second class, third class, and fourth class to the project. These currently do not contain any code outside of their base class declaration. In the main method of the program class, we declared 2 variables and write them to the console to test our setup is working. Static classes have several defining features. You cannot create an object from them, no other class can inherit from them, and they must contain all static members. Static member of non-static classes also have inherited behaviors. They are not available to objects of their containing class. They can be accessed directly through the name of the parent class. And there is no instance information about their parent class required for them to function. One of the most common static classes accessed is the math class within the system namespace. Here we are using the static method of POW to perform a mathematical operation. If we right-click on this method and choose Go to Definition, we see that it is a static method contained within a static class. This method's intent is to provide us with a result regardless of where in our program or how many times it is called upon. Since the math class is static, we cannot create an object of this class. Similarly, we do not create an instance of console class before use. Here we add code to our non-static second class with a static variable, a public instance constructor, and a method that uses a math class to return a value. From our program class, we are able to access the static member through the name of its containing class, as we are in the same namespace. Our console output shows the default value of the double type as 0. We will need to create an object of second class to run the instance constructor and assign a value to h. Despite the object creation, we cannot access the static variable through the instance of this class. The non-static public member of the non-static class, however, is accessible. To demonstrate how a static variable's data is the same from any point of access, we will first assign a value in our program class and set up third class to print the value of h from its perspective. The value assigned through the program class is maintained even when h is accessed independently from another class. In this way, a static member can be used to share common data between different classes. In fourth class, we will declare a static variable with 2 types of constructors that assign values, a static and an instance constructor. Here we can see the result of the assignment from the static constructor. The instance constructor is executed when an object of a class is created. A static constructor only runs once, and execution always occurs prior to the instance constructor or any reference to the static class is made. Lastly, we will add a fifth class to the fourth class.cs file and add an instance constructor. As instance constructors are used when class objects are created, you see the error static classes cannot have instance constructors. However, if you wish to initialize values within a static class, static constructors can be used to accomplish this task. You have now seen how the keyword of static can be used to allow access to members that only require a single occurrence in code, how it can be applied at the class, method, and variable levels, and how to access these members within your code. Thank you for watching.